Hello, and welcome to today's webinar hosted by the Thomson Reuters developer community. I'm Jason Ramchandani, the developer community advocate at TR, and this webinar is part of a series in our developer event program. You can find out about other events at our newdevelopers.tr.com portal, which contains many resources to help you get the most out of your API and SDKs, and also has a moderated Q&A forum you can freely post to. During this webinar, please submit written questions at any time during the presentation using the Q&A panel located at the bottom right of your screen. Your questions will not be seen by other members of the audience and will be addressed, time permitting, towards the end of the session. If you experience technical difficulties during the WebEx session, please dial 1-866-863-3904, or you can try messaging using the Q&A or chat panels. During the presentation, all participants will remain in listen-only mode, and as a reminder, this event is being recorded for rebroadcast. Now, I'm pleased to hand over to Uma Nala from our Platform Services Group, who will take us through the presentation.
Hello, everyone. Thank you for joining us, and welcome to this introduction to the Electron Message API. Now, before we start exploring the Electron Message API, I think we should first identify what Electron Message API can be used for. Okay, as you may well know, Thomson Reuters is the biggest provider of content for professionals in the financial markets, law, and tax and accounting. Now, our products and services can be grouped into 5 logical areas. We have financial, risk management, and news, which generally supports the financial markets and the investment community. We also have legal and tax and accounting. Now, our real-time financial data is delivered via our Electron feed, which is a low-latency, high-performance feed which consolidates content from over 500 exchange-traded and over-the-counter markets. It covers a comprehensive range of asset classes, including equities, fixed income, money, FX, and so on. Now, in order to provide this data in a timely, low-latency manner, we have collection and distribution points all around the world. We also provide data from a range of third parties, including leading brokers such as ICAP, Tullett, Tradition, and so on. Now, real-time news is also available via Electron, as well as analytics and sentiment indices. So the recommended way to consume our Electron data is to use one of our Electron APIs. Now, we do have a low-level Electron Transport API. However, today, we're going to be focusing on our high-level Electron Message API. So what is the EMA? Well, it's an easy-to-use, high-performance, open-source API that operates at the message layer. In other words, the developer generally only needs to deal with data and status messages. Now, it does this by abstracting away the complexities from the transport layer and adding these capabilities on top. And a lot of this simplification is achieved by defaulting various functionalities. So this saves the developer the effort of having to implement this default behavior in his own code. It offers rapid transport, startup, by being very easy to learn, and also rapid development by requiring much less code to be written. Now, it still offers a high degree of flexibility by allowing the developer to override some of the default behavior should the need arise. And it does this while offering high performance and low latency processing of your streaming data. It is available as an open source version on GitHub and also an officially supported version from Thomson Reuters website. So a bit like CentOS and Red Hat Enterprise Linux. Now, in today's webinar, we'll be looking at Java examples and code. However, the API is also available in C++. So all the examples that I will cover today will be in Java, but the equivalent C++ versions are also available and included within the C++ version of the Electron SDK. Okay, now this diagram just gives you a high-level overview of where an EMA consumer application sits. So an EMA consumer application is an application which consumes Electron data, real-time data. It would typically connect to your market data system, i.e. the Thomson Reuters Enterprise platform. From there, you'll be able to consume Electron data as well as internal data and third-party data available on your site. Okay, so now before we start diving into the nitty-gritty, let's just run a simple consumer example and see the output. So before we can run the example, obviously we need to install the Electron SDK. So this is very straightforward. You can download the SDK from the Thomson Reuters website or from GitHub. And you just unzip the package, and that should be it. I will show you the locations of the downloads later on towards the end of the webinar. What we're going to run today is one of the most basic examples that comes with the Electron SDK. And the example is example 100, market price streaming. Now, I should just briefly explain the naming structure of our examples. So the Electron Message API comes with a series of examples, and the most basic ones, series 100, and then you have a series 200, 300, and 400 increasing in complexity. So this one is one of the first examples, and it's a market price streaming example. And what this example does is it connects and logs onto a server. It then makes a request for some market price data, hence the market price in the example name, and then it establishes a message stream. So it requests the initial message and then expects to continue receiving messages as and when the market state changes for that instrument. And then as it receives the messages, it will process the responses and then parse and output the data. Now obviously, to run an EMA example, you need various libraries. And to save you having to root around in the documentation and find a list of the libraries, we include a script which helps you run the example. There's a Windows BAT version and a Linux Kish file as well. And it's called example 100, market price streaming, and you'll be found in the example sources folder. Okay, so let's go ahead and run the example. See, so the example is connected and it's received some data. I'll just quickly scroll up and show you. The first thing we received is something called a refresh message, which is a header section. I'll explain all this in a bit more detail in a moment. And then followed by that is a list of fields. We've got several hundred fields containing the actual payload data. And after that, we can see several update messages. Okay, well, it's a bit tricky to view this on this console, so let's go back to the slides and look at the stuff here. Okay, before we actually look at the data, let's just do an overview of what just took place. So the interaction that happened was the application sent a requested some data from the server, and it was a valid request, so the server responded with a refresh message. A refresh message is basically a list of all the fields that that particular instrument can possibly deliver. And then after that, we received several update messages. Now obviously, the number of update messages you receive will depend on when the application is running. So if an application was running during market open, you may expect to receive a high level of updates. Whereas if an application was running during, say, market close period, you wouldn't expect to see any updates. You only see a refresh message. So okay, now as we saw on the console, the first thing that got back was a refresh message. And the top of the refresh message was a header section. And this contains various attributes and properties of the actual response we received. It includes things like the actual name of the instrument and also state information. So here we can see we've got a state of open and OK. And the open reflects the actual stream state. So we establish a message stream. It's saying, yes, your message stream is open, it's fine. And then the OK represents the actual quality of the data. In other words, the data is okay as well. If, say, there was something wrong with the data, you may have a suspect status there. Okay, and after the header, we then have a payload of fields. So here on screen, I've got an extract of a partial field list, a partial payload. And you can see there's a list of fields here. And each field has a field ID, a name, a type, and the actual value itself. So here we've got field number 5, which is time of activity, of a data type time, and a value. We can also see some price type fields. So we have field 22, which is a bit field, which again is type real, and a value of 103. We also have enumerated type fields, so we've got the currency. Now this particular refresh belongs to Japanese yen requests that have been made by the person. So this value 392 actually represents Japanese yen. Okay, then followed by the obviously a refresh message will have several hundred fields, and we've just got a few here. And then followed by the refresh, you will then receive update message. This will be again as and when there's a change to the state of that instrument in the market. So if a price changes or whatever, then you would expect to receive an update message corresponding to that. As you will notice, the actual payload of an update is much smaller. This is because an update only reflects those fields that have changed since the refresh message or a previous update message. Again, the same kind of information. You have a field ID and so on, type and values. Okay, so now we can go into a bit more detail about EMA. Now, the Electron Message API is data neutral in that it does not apply any business logic. It just passes the data through as it receives from the server. It is also multi-threaded. In other words, it is thread safe and thread aware, and it operates asynchronously. So by this, what I mean is that your application makes a request to the API, and then the controllers return back to your application. So the application can carry on running and performing other processing. When a response is received from the server, the API uses a callback mechanism to send the message back to your application. We'll cover this in a bit more detail shortly. And it's message driven in the sense that all your interaction with the API is via high-level messages. And the messages typically contain data or status information. An EMA uses binary representation. In other words, unlike some other APIs that represent all the data as string formats, or even things like prices and quantities are in string, which require the developer to then convert that data into numeric, EMA actually represents that in binary formats. We saw from the field list that the price type fields were of type real. So the developer does not need to do any conversion and can just perform calculations on the raw data. It also uses common container classes, things like arrays and maps and so on. And it also makes use of defined data formats to represent things like yield curves or order books and so on. Okay, so what is a typical life cycle of an EMA consumer application? Well, the first thing an application needs to do is establish a connection to the server. Now, this is done by default by the API. And then it needs to perform a login. Again, this is done by default by the API. Obviously, the developer does need to provide some information, i.e. the name of the host name or the IP address of the server, and also the username to use for the login. Now, once the actual connection has been established and a login has been successful, then it's up to the developer to provide some code to issue a request, and also then to provide some code in the callback methods to actually handle the responses and decode them and so on. And finally, when the developer wishes to stop receiving data, he needs to do an orderly logout and shutdown by calling an initialize method. Okay, now I think the best way to show you all this is by writing some code. So let's go ahead and write some code. But before we do that, let's just explain the asynchronous mechanism in a bit more detail. So as I mentioned, EMA uses an asynchronous model, and this helps avoid performance bottlenecks and also enhances the overall responsiveness of the application. So how does this actually work? Well, the application requests an instrument by registering its interest for that instrument with EMA, and then the controller return back to the application thread. And now then EMA then makes that request to the server behind the scenes. And when the EMA receives a response from the server, EMA dispatches a message, and then it executes a callback to pass that data back to the application. And it does that by using a consumer client class. So there's a EMA consumer client class, and what the developer needs to do is derive a class from that, and in there provide implementations of the callback methods to handle the messages. Now, the dispatching of the messages and the execution of the callbacks are both done by the EMA using its own thread of control. Okay, I think the best way to demonstrate it is to write some code. So let's go ahead and do some code. So I'm just going to jump into my editor. Okay, now what I've got here is a kind of bit of a shell of a application, and it contains two classes. We've got a consumer class which I've written, and also in my implementation of the OMM consumer client, either one that has the callback methods and so on. So let's just go ahead and look at the consumer class first, which contains a main. Now what this is going to do is it's actually going to initialize a config, create a consumer, connect to the server, log in, make a request for the data, and so on. So let's actually go ahead and write some code. So first I'm going to declare an OMM consumer. Now OMM consumer is a main interface between the application and the Electron Message API. It handles things like the requesting of data and all the transport level stuff which it does behind the scenes. Okay, now we're going to create an instance of our callback client, which we've defined above. Okay, next we're going to create a config container. For this, we're going to use the EMA factory, which is an EMA class which is used for the creation of OMM containers and objects. Okay, now executing this line of code will create a default config container, and the API will set all the config parameters to default values based on most common usage scenarios. Okay, so now we're actually going to create our consumer. Again, we're going to use the EMA factory. Create OMM consumer, and obviously we're going to pass in the config, but as I said, the config above is just contains default values, which is not really, we need to override this and actually provide some meaningful values for this for the server we're going to connect to and the username. So let's go ahead and do that. So we're going to specify a host. So I'm going to specify a test server that I use here. I'm going to specify the username for the connection. So I'm going to use test1, which is a defined user on the server. Okay, next I'm going to create a request message we're going to use to actually request our data. Which is again going to be using the EMA factory. Okay, and next we're going to register this request message with the OMM consumer. Oh, I should have mentioned that when this line of code is executed, it will actually, this line here, it will actually make an attempt by trying to connect to this server ADS1 and then try to log in using the username test1. Okay, so back to this request message. So consumer.register client. We're going to put in the request message, and also we're going to specify the app client. In other words, we're going to tell the consumer that when you receive any responses from the server that corresponds to this request message, then please call the callback methods within this instance of the app client. And obviously, our request message there just contains default values. We actually need to override those and specify, tell the API what it is we want to consume and where we're going to consume it from. Now, the first thing I need to specify is a service name. Now, the reason I need to specify a service name is that the server I'm connecting to, and most likely the servers you'll be using on your site as well, there will be multiple sources of data. So we'll have Electron data, we'll have some internal sources of data, and perhaps even some third-party data on your servers. Obviously, each of these sources has a service name. So on my particular server, the service name for the Electron feed is Electron DD. Specifying that, and also I need to then specify the name of the instrument I need to consume. So I want to request Vodafone from the London Stock Exchange. Okay, so that is our connection login and request done. Fine, I'm just going to write a bit of code to do a clean shutdown when the application terminates. So this application is going to run for 60 seconds and then it'll do a logout and shutdown. Okay, so that's our main class. Now let's move on to the actual callback client. So again, this is OMM consumer client class, from which I've derived my class called app client. And in there, as you can see, I've got some empty callback methods. So I've got one here for handling refresh messages, one for handling any update messages, and one for a status message. Now, because this is a simple example, I'm just going to, and also because we're short on time, I'm just going to dump this out to the console. Okay, now the refresh message has a toString method on there, which that will use. I'll do the same for, update message, and finally for status message. So that's all fairly self-explanatory. So when we receive a refresh message, the API will call the onRefresh message handler, and it'll call it onUpdate for an update message. Also, we've got this onStatus message. Now, I've not really talked much about status messages. Now, typically, if there's a change to the status of an instrument, like for example, if the instrument goes stale because the data is flagged as suspect or whatever, then you may receive you would receive an onStatus message from the server, and that will contain state information as well as a textual explanation of the state as well. Okay, we have a few other callback methods here which we've not implemented because they're not really applicable for consumer applications, so we'll leave those for now. Okay, so that is it. That is a full consumer application. And I said, you know, EMA is an easy-to-use API, and hopefully this has demonstrated that. So let's actually go ahead and run this now, shall we? So I run my simple consumer. Okay, we've got some data. I'm going to stop that. So again, as you can see, we have a refresh message for Vodafone L from Electron DD, followed by all the fields, and then we receive several update messages. Okay. Let's move on. Okay, now I did mention earlier that it uses an asynchronous model, and that EMA by default dispatches the messages and executes the callbacks using its own threads. Now, there may be occasions where the application wants to take control of the dispatching and also execution of the callbacks using the application level threads. Now, one example of where you may wish to do this is when you're consuming, high levels of data, and the instrument's a very volatile market, and you want to control the rate of dispatch and so on, or you want to kind of find a balance between dispatching messages and executing the callbacks and requesting new instruments or performing other processing. So, if the application takes control of that, or the user takes control, then obviously they can tune that and control the rate of dispatch and so on. So for that, you use something called user dispatch mode. Now, how can we achieve this? Well, it's fairly straightforward. When we create our consumer config, it defaults to API dispatch as the operation model. So we just need to change that and can replace that with operation model of user dispatch. So let's just go ahead and do that. Operation model dot user dispatch. Okay, and now obviously if we're going to take control of the user dispatching, then we also need to provide some code to actually perform the dispatching rather than relying on the API to do it. So here, there's a very simple bit of code here. Now we're just going to loop around for 60 seconds, and then in that we're going to be calling the consumer.dispatch method, and I've specified a value of 10 there. And what that signifies is that we're telling the dispatch method to wait up to 10 microseconds for a message to arrive, and if one does become available, to dispatch it immediately. If, however, no message arrives within those 10 microseconds, then to leave the dispatch method and return control back to the application thread so that we can perform some other processing like requesting more instruments or some other application level processing. Okay, so that is a user dispatch model. Okay, while we're looking at this example, I'll show you a bit more code. And obviously, the previous example we looked at, the callback method is very basic. We just used the string to method to just dump stuff out to the console, which is not something you do in real life for a real application. So here, we'll just show you typically what you may want to do now. On this on-refresh message is a bit more detailed. It's actually extracting things like the item name and the service name, dumping them to the screen. But then the important thing to look at here is that it's checking the actual data type of the payload, and if it is a field list, it's then extracting the field list and calling a decode method within the application. So let's go and look at the decode method. Now the decode method obviously has been passed the field list, and all it's doing is iterating through the field list, extracting each field entry. Then for each field entry, it's dumping out the field ID, the name, and the value. Now here, obviously, you would more likely iterate through the field list, extract the fields that you're interested in, and then perform your processing on those fields. Okay. Now let's move on to the next slide. Okay, now EMA offers quite a few other additional capabilities and functionalities to help make the developer's life easier. Now, one of these is the ability to easily consume complex content such as level 2 market data. So most of you should be familiar with the idea of level 1 and level 2 data. So obviously level 1 covers things like current quote, mid-price, trade price, and so on for an instrument. But level 2 covers things like depth of market and full order book. So for example, depth of market is market by price, where that's a view of the market ordered by price point, i.e. number of orders at each price point. And then you have market by order, which is a list of all individual orders on the market. So if we were to make a level 2 request, what would we get back? Well, let's take an example of market by order. If you were to make a market by order request, you would get back a collection of orders. Now, at the top, within the collection of orders, you would first have, say, a summary data section, which would contain values which are common to all the orders within the collection. So here, for example, here we have like the summary data section, we have the currency, trade units, and exchange IDs. So for example, if this happened to be Vodafone from London Stock Exchange, all the orders for Vodafone will be within the sterling currency, and obviously all originate from the London Stock Exchange. And then followed by the summary data would actually be the actual collection of orders themselves. Now each order will include information such as the order price, the size, and the side, and so on. And then also each order will have a unique order ID as well. Now typical, when you make a request for a market by order, there will be several orders, maybe 100 or so, just depending on the, volatility of the instrument that you've requested. Okay, so how do you actually make a market by order request? Well, it's quite simple, and I'll show you the code to do that. Okay, so this is the market by order example. So again, this is included within the Electron SDK. It's a Series 100 example, and it's example 140. Okay, now as you can see, a lot of the code, most of the code looks very similar. We've got a consumer, app client, create on consumer. Now the only difference we can see here is this bit of code here. Now, when we ran the original application, which was a market price application, EMA defaulted the request type to a market price application. Obviously now we need to override that and specify a different what we call a domain type. So we're going to use a domain type of market by order here. So we override the default and say domain type market by order. And all the other code remains the same essentially. So we're looking at specifying a host name, username, service name, and instrument name, and passing in the app client as well. Okay. The other difference will be, obviously we haven't got time to go into this in full detail here, is that the collection is delivered as a map. So we have to actually extract the map. And then within the map, we'll have a map entry for every single order, and then each map entry will actually have the payload, the size and price one in a field list. Now, obviously, we can't go into too much detail here, but there is a tutorial on the developer portal which explains all this. And at the end of the webinar, I will show you that tutorial for your reference. So for now, let's just go and look at the output from this. Okay, here we go. Right, I think that should be enough. So what we've done here, we've made a market by price request. So first of all, at the top, you can see we've got summary data. So we've got things like the currency, the ordering rules, and so on. And then we actually have the orders themselves. So we have each order has a order ID, price, size, and so on. Okay, so that's our market by order. Okay, now the examples we've run so far have all been what we call streaming examples, in the sense that we've established a message stream, we've received a refresh message, and then we've continued to receive a stream of updates as and when the market changes for that instrument. Now, there may be occasions where you're not really interested in receiving a stream of messages, you just want to receive the current state of the market for that instrument, and then you don't want to receive any more messages. So the way you would do that is you'd make a snapshot request. It's quite easy to do that. You just, in your code, you override the default, because the default would be to make a streaming request. So what you would do is, or change that by telling the API, the actual in the request message, specifying that after you get your refresh message, you're not interested in any more messages after that. So we set interest after refresh to false. So if we run this, we should see. So we've got snapshot. As you can see, we're running during market open. We've received our refresh message, but even though we've been running for several seconds and we've requested IBM, we're not seeing any updates. Okay, now all the examples we've run up to this point have requested single instruments, but in reality, if you write a production application, you're probably interested in requesting several, perhaps hundreds or even thousands of instruments. Now, EMA, to help you in this, EMA does offer a batch request functionality, whereby you can request multiple instruments using a single register client call, a single request message, and then receive individual responses for each of those instruments as and when there's market activity for those instruments. So how do you actually achieve this? Well, let's go ahead and look at the code for that. So we've got batch. Okay, now this again is an example which is included in the dev kit. And it's a Series 300 example. Mark example 370, market by price batch. Okay, now the way we do this is, first of all, we create an element list. Now, an element list is a heterogeneous collection which contains, you can use to store different types of, containers in there, objects in there. And we use that to allow us flexibility in the future. At the moment, we're then going to create an OMM array and add that as an element in the element list. In the future, we may offer additional types you can embed within the element list. And the other reason we use an element list is because each entry in the element list is self-describing, and so that allows more flexibility. So we create an OMM array. And then again, we use the EMA factory for both of those things. And then to the array, we're going to add two instruments. We're going to add Thomson Reuters from NYSE and IBM from NYSE. Again, I'm only adding two instruments here because this is a simple example. In reality, you'd probably be using reading the instruments in from a flat file, or doing a SQL query or something and using the response to populate the array. And then we add the array as an entry into our element list. And then we actually describe it as being a item list. And then we actually add that entry to the batch. And then we call a register client and pass it in a request message. We're creating a request message on the fly here. And again, we're specifying a service name. Now, the one thing you notice different here is rather than specifying a name and putting the instrument name in, we're actually specifying payload and passing in the actual batch as the payload. And finally, we're specifying the callback client that's going to receive all the response messages for these instruments. Okay, so let's go ahead and run that. Stop that. So As you can see, we're seeing stuff for Thomson Reuters, IBM, Thomson Reuters, and so on. Okay, so that's batch requests. Now, as I mentioned, in reality, you probably will be requesting, hundreds of instruments, perhaps even thousands. Now, if you are going to be requesting, thousands of instruments in a volatile market, this could mean a very high number of messages to process during, say, peak periods. In which case, it would make sense to distribute the processing of these messages across multiple threads, especially when we're using the modern multi-core CPUs. Now, we noted earlier that by default, EMA executes the callback methods in the API thread, and we can override this to execute them in an application thread. Now, you can take this further by allowing the developer to create multiple consumers, each running on a separate thread, and thereby spreading the load across multiple cores. So here we can see that this application has created 2 OMM consumer instances, each with its own dispatcher thread and a callback message processing thread. So the advantage of using 2 consumers would be that the threads would get spread across the cores, and thereby the processing of all the high levels of updates and messages would be distributed across the available CPU cores as well. Okay, well, how would you achieve this? Well, again, the API includes, package includes one example, shows one way of possibly doing this. Okay, so we've got a horizontal scaling example here. Now, the way we've done it in this example is we've created a class called consumer instance as a runnable, so it can run it on its own thread. And what the consumer instance class does, it actually creates, each instance of consumer instance will create its own OMM consumer. And what that means is obviously that each OMM consumer will then have its own, as I've explained, its own dispatcher and callback thread and so on. And then within the main itself, we're creating 2 instances of consumer instance, and then using each instance to request different instrument. Clearly, we're just requesting 2 instruments here. In reality, suppose you had a few thousand instruments, you'd probably split the load between each instance of your consumer, and thereby spreading the load across the CPU cores. Now, the other thing worth noting here quickly is that I'm actually connecting to each instance to a different server here. So I'm passing obviously ADS1, ADS2, which are then used within as the actual host value when we create our consumer and specify the config. Now, so what this means is, as well as distributing the load at the application level and at your PC level, if your environment and your market data system allows it, you could even actually distribute the requests across multiple servers. So if you have enough capacity on your site, you can actually send some of your requests to one server and then requests to a different server, thereby spreading the load on the market data system as well. Okay, so that covers market horizontal scaling. Now, that kind of comes to the end of our kind of demos of examples. Again, I've just covered a few examples here. The thing is, the EMA package comes with a whole set of examples. I mean, there's a series of examples. We have series 100 examples, and then the increase in complexity is series 200, 300, and 400 with the most complex ones. And between all of them, they cover most of the functions and capabilities that are offered by EMA. Obviously, to run an EMA Java application, various libraries are required, as shown on screen here, and all these libraries are included within the Electron SDK package. Now, to build EMA Java examples, we provide a build.xml file. So all you need to do is install and configure Ant, and navigate to wherever you've unzipped your Electron SDK into the source examples folder, and run the Ant command. And all being well, you should see a build successful message appearing, and all your application examples should have been built for you. Also, as I mentioned right at the beginning of the webinar, EMA is also available in a C++ version, and it's been qualified on the OSs and compilers that are shown on screen here. And again, just to confirm that all the examples we've seen today are also available within EMA C++. In fact, it contains pretty much the same set of examples as the EMA Java package. So you have series 100 to 400, and between them that covers all the functionality and so on. Okay, well, now hopefully after seeing this webinar, you're going to be keen to go and have a play with the EMA yourself and explore it and use it. Now, obviously, you may need some help with that, perhaps. And as I mentioned previously, you can get hold of the API from GitHub and from the Thomson Reuters website. Now, for the best experience, I personally recommend that you go to the Thomson Reuters developer portal. And from there, not only can you download the API, you can also access tutorials, documentation, and also interact with other developers and so on our Q&A forum. So let's just head over there and show you around a little while. So I'll just quickly show you the GitHub. So on GitHub, it's actually available under Thomson Reuters Electron SDK. You can just Google GitHub Electron and it should be one of the first hits you see. And obviously, but as I said, the best place to probably go is to the Thomson Reuters developer portal, where you'll need to register. You can register using a corporate email address or even a personal email address, and it's free to register. And once you've registered and logged in successfully, you should be able to access all the resources. So know that the first thing you'll want to do is, because this is a landing page which kind of lists all the different APIs and so on that are available from Thomson Reuters. So the first thing you'll probably want to do is click on the Electron link, and then click on the actual language that you're interested in. So say we go to C++. The first thing you'll then do is go to Downloads and download the latest version of the API. On this page, you'll also find some tutorial source code as well, which I'll show you in a moment, and a few other tools and so on. Okay, now once you've downloaded it, the next thing I would recommend you do is go over to the Quick Start page. Now, what the Quick Start page is just helps and talks you through kind of unpacking the dev kit, configuring it and so on, and then building an application and running it and such like, and it also includes some basic troubleshooting and so on. Now, the one thing to note is that before you can actually run the Quick Start, you will need to contact your market data team and obtain a few bits of information. So you'll need to get hold of your host, the server IP address or port or IP address. You'll also need to get hold of a valid username for the server, and also the service name you need to use to request Electron data or perhaps some internal data. So once you've done the Quick Start, I would recommend you then head over to the tutorial section. And in here we've got a set of quite easy to follow tutorials, which start with creating a really basic bare bones application, just setting up the environment and so on. And then it moves on to actually requesting a market price data. And each step is explained in a reasonable amount of detail. Then decoding the market price data. And then it also then moves on to requesting a processing level 2 data, so dealing with the payload and so on. And again, there's a video associated with that. There's a few more, slightly more advanced tutorials if you're interested in. The same applies for the Electron Java API as well. So if we go and have a quick look there, we've got tutorials. Again, bare bones, requesting market price data, parsing market price data, and level 2 data, and so on. Okay, now suppose you've been through the tutorials and so on, and you've got a few questions, then next thing you should do is head on to the question and answers section. That'll take you to our forums. Now on the forums, you can see they're grouped by API, so click on the Electron link. The first thing I recommend you do is just do a search to see if the particular topic you're interested in has already been answered or covered by somebody else. Or if you can't find the answer you're looking for, then just click on Ask a Question. And when asking a question at the forum, try and include as much information as possible, including console outputs, any error messages and so on, so that the person who tries to help has as much information available to them as possible. And that draws into our presentation, and we're now going to wrap up with a Q&A session. Thank you.
Hi everybody. So that's the presentation from Uma done, and now we're going to go into a Q&A session. We had quite a few questions come in, so let's start with those questions. So we had a question, will the refresh message always provide the list of FIDs field IDs for a particular instrument.
Mm-hmm. So
who's that? Is that Nawapum or Jirapong?
Jirapong, yeah.
Hey, hi. So you got that first question?
Yes. So I think for this question, you mean about the market price domain. The market price domain, the payload of the market price is a field list. So if the link is valid, the refresh message will contain all possible fields for a particular instrument. However, each instrument may not contain the same set of fields because it depends on the exchange. The one thing that we should aware of that if application use view dynamic view feature, the refresh message does not represent the actual field set because they are filtered by this feature.
Okay, that's great. Another question came in, which is how can we convert enumerated data, enum data?
Oh, the EMA Java does not provide interface to get the decoded enum value. The EMA Java keep the dictionary, you mean the RDM dictionary and enum type.def internally. However, it is open source, so you can modify it to get the decode enum value. There is an example code in the community, in the Q&A forum, so you can see it there.
Okay, so is there a link for that?
Yeah, it's a link. Yeah, you can search about the decoding field list contents with field and enumeration.
Okay, so
yeah.
All right. So if there's a link, could one of the team put that in the chat window? Thanks very much.
Sure. Yeah, I can put the link to the chat window.
Okay. In the code sample, another question we had came in. In the code sample, where and how is the data dictionary loaded by the application or EMA API?
Sorry, shall I take that? Actually, as I mentioned in the application lifecycle slide, a lot of the stuff is done for you behind the scenes by the API, and one of the things I didn't actually include the actual data dictionary bit in the slide because I want to keep it simple, but essentially that's done for you by the API behind the scenes. So all you need to do is configure the settings in the config file, so that you either sort of say you want to load it from a local data dictionary file, or you can say it's a download from the server, and so those are the two options, and it's all done for you. As long as you set the appropriate config, the API will do all the downloading and parsing of the data dictionary for you.
Great. We have another question which has come in, which says, does EMA have a configuration option to ask EMA to handle ripple fields in response, or does the application need to write code to handle the ripple field values, like we do at the moment in the RFA API, which is a previous API which is being used now?
Yeah, I think it's the same as RFA in a sense, but we do provide an example. So if you look in the Series 200 folder, there's an example 240 market price ripple fields, and that demonstrates a technique for how to actually handle the ripple field in the code. So
right, so the application would need to. The application
exactly.
Need to handle.
That's okay. Right. Yeah, because we provide the example code for doing that anyway. So.
Okay, perfect. And then we have another question. Is it recommended to load the data dictionary from the ADS or locally?
I think this is the same rule that's applied for any of our APIs. It's always generally recommended to download the dictionary from the server, because obviously otherwise it's down to the actual application owner to have the responsibility of constantly updating dictionaries if they're keeping it locally or on their own server or something, because Reuters do, regularly issue new data dictionary files as and when exchanges, kind of add, change the data format, or we add extra FIDs to handle, newer data and so on. In fact, some organizations, some banks and so on, they insist, all developers, as a rule, always download a dictionary, and they kind of, frown upon people using local data dictionary. So yes, generally it's recommended to always download the data dictionary.
Okay, so let's see. Okay, we've got another one here. You say EMA sets a lot of the config to default settings, and then how or where do I find the defaults, and how difficult is it to override these defaults?
Okay, well, again, I didn't cover these in the slides too much because I didn't want to kind of overcomplicate things, but the actual default settings are detailed in one of the PDF files that comes with the dev kit. There's like a config PDF file which lists all the parameters and the default values. And like some of them you can override within the program source code, things like the host name, the server IP or port number, and so on. The other things, there's the way the config works is when you create a config object, the EMA tries to find a EMA config.xml file, and obviously if it finds that file, then it'll load the various parameters from the config file that the developer specified and use them as the values. But obviously, if it can't find the EMA config file, then it will just set them to the defaults as detailed in the config document. And you can find that in the source folder. When you unpack the Electron SDK, look in the EMA docs folder, you'll see, and then you'll find the config PDF file.
Right. We've got another question. For bid ask, bid size, ask size up to 5 levels, can the market by price domain be used?
Market by price, again, when we're looking at sort of normal data formats, there are some RICs where you can request a market price RIC, and it kind of gives you top of order book, like the top 5 or 10 prices and so on. But again, this kind of depends on the exchange and so on, whether that particular data is available on that particular, provided by Reuters on the exchange. However, when you make a market by price request, that will return a full list of all depth. So in other words, it could be like several hundred, list of orders by price on there. So then it's up to the user to extract just the top 5. That's all they're interested in.
Okay.
So for top of order, if you've got an existing RIC that you're used to requesting, where it gives you top of order book and gives you the top 5 or 10, you can still request that RIC and use a market price by the default domain. However, if you want fuller order book depth, or if not on that particular exchange or whatever, if there is no RIC available from Reuters on the market price domain that gives you order book entries, then you can make a market by price request and get the full order book. So there's 2 ways of doing that.
Fantastic, thanks. So another one. On the market data diagram you showed, you also had a direct connection from the consumer app to the Electron field, which avoided TREP. How and why would you do this?
Well, the first thing you need to do is really check with your market data team if they let you do that. But if they do, then you could connect your application direct to the Electron feed. And the way you do that is just literally just change the IP address or the server name within the config to the IP address or server name for the actual Electron feed as provided to you by the your market data team. However, this is it's used in exceptional cases where you require like the absolute lowest latency. So, for example, if you're writing an algo trading app, then you may be given permission by your market data team to connect direct to an Electron feed. But again, this is quite exceptionally used for exceptional scenarios, and there are drawbacks in that you lose some of the features that the TREP offers. Obviously, connecting via TREP, you gain things like failover, resiliency, scalability, and so on. That's offered by the market data system. But by going direct, you'd lose some of those features.
Mm-hmm. Okay, we've got time for a couple more, I think. So another one, you mentioned that the refresh message contains every single field, and the update message also has all the changed fields. How do I just get a few fields, e.g. bid, ask, trade price, and so on?
Okay, well, one way of doing this is by using something we call a dynamic views functionality. Now, there is an example that covers that within the tutorial. Let me just find the right example. But essentially, the way that works is you create an array of the FIDs you're interested in, and then when you make your request message, you pass in the list of those FIDs as part of the request message, and that actually is sending the request off to the server, and you're actually asking the server to filter the fields on your behalf and send you back a response which has just those filtered FIDs. And the example actually is example 360 market price view. One thing to bear in mind is this is just a request to the server, and you're not guaranteed that the server will filter those FIDs for you, because if it's too busy serving other customers, other users, and if it thinks it impacts the ability to serve the users, it may still send you a full list back of all the FIDs, depending on whether it's capable of doing that or not. So you can use the dynamic views functionality, but always be aware that any one point in time, if the server's too busy, it will send you a full list and it won't do the filtering for you. So that's one way of doing it, now using dynamic views. The other way, for example, in the C++, EMS C++ thing, we've also got like a field search function where once you've got your full field list back, you can again use a special iterator where you pass in a collection of FIDs, and it will then allow you to iterate through the field list, but it'll just kind of do the filtering for you at the application level, so that as you kind of say next going to the iterators, it'll just go to each FID in your kind of collection of specified FIDs. So that's an application level filtering, but it's available in the EMS C++ version. So there's two ways of doing that.
Thank you. I think we've got time for more questions are still coming through. It said, we have a speed guide tool in the download tab in the developer website. What exactly does that tool do?
I think it's just a way of viewing data and so on. You could probably sort of use it as like a diagnostic tool. So if for example, we have what's called guide pages on Reuters, where sometimes it helps you find data. So you might say if you're looking for say money data, you could try and look at the money guide speed guide page, and it'll help you try and narrow down the RIC you may want to access certain asset classes and so on. But I mean, it's a general purpose of viewing tool for viewing data. So and you could use it, for example, if you're running an application, the data doesn't look quite right, then and you're not sure whether it's a bug in your code or whether it's issue with some data coming downstream, dodgy data coming downstream, then you could use a speed guide tool to request that the same RIC, view it using that. So it's just like a GUI viewer application, and then you can use that to check the data you're seeing in there, and then comparing the data with what you see in your application to make sure that the data is coming down correctly from the feed, and if there is some discrepancy, then it could well be a problem with your actual application. I mean, there's another so I mean that's the main use for it. But again, it's also used sometimes to help you to track down a particular RIC or whatever by narrowing down data. Otherwise, you can always call our data help desk or whatever, and try and get them to help you advise you on which RIC you want to use for a particular instrument that you're trying to request.
Okay, so I think we're kind of running out of time here. We do have other questions which we simply probably can't get to because of the time. So firstly, so basically we'll be transferring some of those questions onto the forum, onto the Electron forum, and then you can continue the conversation there. So first of all, I'd like to thank Uma for this technical webinar. If you have any further questions, feel free to continue the discussion, as I've said, on our community Q&A forums. You will also find more developer documentation, code samples, and video tutorials there, as Uma has showed you, as well as details about forthcoming events. Finally, thanks to all the participants. We hope you found this helpful. and interesting. We want to be able to serve you better, so we'll be sending around a brief survey and would appreciate any feedback on this webinar or any suggestions you may have for future topics of interest. I'd like to wish you all a great rest of the day wherever you are in the world. Thank you very much.